All right, so welcome to part 4 of section 1.5. So here we're going to look at graphing functions with stretches and compressions. So we're going to look at vertical stretch and compressions first, and then after that we'll look at the horizontal stretch and compressions. So here we have, again, some function f of x, and then we're going to get a new function g of x by taking a times our f of x. And so the key is we're taking that a times it. And a is going to be some constant, and it's going to be a vertical stretch or compression factor. And so if a is greater than 1, it's a stretch by a factor of a. So we're going to take a times whatever f of x is, and we're going to stretch it, okay? And how we can look at that is if we have our original function here in blue, that's f of x. If we have something greater than 1, say the 2, then we're going to multiply each of these times 2. So this becomes up here 2 times higher, and this one comes up 2 times higher, okay? Now, if a is between 0 and 1, this is going to become a compression factor. It's going to be pushing it down towards the x-axis, and basically we're going to multiply that value up. So it's probably going to be maybe a half or 2/3 or something like that. And so in this case, we used a half, and so half of this comes down to here, half of this is down to here, and so on. And so we're compressing it down towards the x-axis here. Now, if a is less than 0, this is going to be a combination of a vertical stretch or compression tied with a vertical reflection about the x-axis. So it's, it might come down, but it's also going to reflect across the axis here, and so it's going to look like that. But then we're going to take these in 2 steps, and so we would do, the compression first, and after that we'd do a reflection and kind of go through there. But this is just strictly the stretches and the compressions. Now, one thing to note is this is how it looks for something like this. Now, if you think about how maybe a parabola would look. Now, if we're stretching it up by a factor of 2, this becomes up here, this comes up here, this would come up here. And so while it's called a stretch, it kind of looks like we're compressing it in, but we're stretching it up. And the other one, if we do a compression down, it's going to come flatter this way, and it's going to go flatter this way because we're pushing it down. It's half or a third or whatever it is, and it's going to go down. And so that's one thing to know is depending on your shape of your original graph, it's going to look different. A stretch, here makes it look bigger. A stretch here kind of makes it look skinnier. And so you have to really remember what the stretch and the compressions do. Now, horizontal stretch and compression, given f of x, a new function is going to be g of x equals f of bx. So we're taking a b times the x inside here. Now, the b is a constant. It's a horizontal stretch or compression factor. Now, if b is greater than 1, say we have 2, 3, 4, or whatever, then the compression is by a factor of 1 over b. Now, if b is between 0 and 1, it's a stretch by a factor of 1 over b. And so if you think about that, say if you have a half, 1 over a half ends up being 2. And so that's a kind of a key thing there. And so you're going to multiply your x value by 2. And here, when you have something like 2 as a b, it's going to end up being a half. So you're going to take half of your x. And so it's going to be something different. Now, if b is less than 0, it's again going to be a combination of a horizontal stretch or compression with a horizontal reflection about the y-axis. Now here, basically, we're multiplying all input values by 1 over b, no matter how you look at it. So if it's 2, it's 1/2. If it's 1/2, it becomes 2, and so that's how we're looking at it. Now here, what we have is the blue is our original, and so if we have a b greater than 1, say have b is 2, we're going to take and multiply everything by 1/2. And so I'm not sure what a good value here. Maybe this would be, if we take the 2 times the half, we could go over here to the 1. And if we take this one, the 2 here times a half, we go over here to the 1. And this is negative and this is positive. And so actually, these are coming in to get to that point here, and this is coming in to get to that point here. And so this one, it's a horizontal compression, but if you remember what I was talking about over here, that's also kind of looks like a vertical stretch. So horizontal compressions and vertical stretches kind of behave the same. And then here, if we have a half for our b. Remember, 1 over a half is going to be 2, and so what was here at 2 now becomes over here at 4, and what was here at -2 becomes -4, and so it kind of comes out like this, and that's going to be kind of like the vertical compression, whereas here it's a horizontal stretch. And so compressions and stretches horizontally kind of do the opposite of what they do with the vertical stretch and compressions here. So that's something to remember, and that's because we have that 1 over b factor, and this one we multiply all the outputs by a. All right, so that's horizontal stretch and compression. So now let's kind of create tables, and this is so if we have to draw something, we can actually draw it and go from the table. Eventually, we'll be able to go from a graph and just kind of do it directly from there. All right, so if we have 1/3 times f of x, what is that going to be? Well, now if you forget, that's going to be kind of like your a times your f of x. And so basically we're going to take a times all values of f of x. And so that means our x values don't change because we're not changing anything here. So our x's stay 2, 4, 6, 8, 10, but our g of x now is going to be 1/3 of whatever our f of x is. So 1/3 times 1 is 1/3. 1/3 of 3 is 1. 1/3 of 5 is 5/3. 1/3 times 7 is 7/3. And 1/3 times 9 is 3. And so that would be the 1/3 f of x here. So that's the vertical. Now here we have 1/4 x, and so this is where we have our b, and so this is going to be a horizontal. So this is vertical, and this is horizontal. Now remember, 1/3, if you forget about that one, we go over here, if we have 1/3, it's a compression. So that's a vertical compression. And here, with the 1/4, that's going to be a horizontal, and it's going to be a stretch. So it's going to be a stretch here. And so it's kind of good if you can kind of remember all the 1 and 2 values, at least for the a's and the b's on what they are. All right, so remember what we're going to do is we're going to take the reciprocal of this times our x values. So the reciprocal of 1/4 is 4, and so that means we're going to take 4 times our x's. So 4 times 4 becomes 16, 4 times 8, 32, 4 times 12, 48, 4 times 16, 64, 4 times that's going to be 80. Now our g of x, it doesn't change. It's 3, 4, 5, 6, and 7. And so that's how we're going to use these. And again, depending on what your b is here, you take 1 over b, and whatever our a is here, you just take a times the output, your f of x, okay? So now here's a summary of all the transformations. So we have vertical reflection, and that's g of x is equal to negative f of x. Our horizontal reflections is g of x equals f of negative x. We're plugging in negative for horizontal x, and here we're changing the y, the whole y, so that's a vertical reflection. Now we have vertical stretch by a, and it's a times f of x, and that's if a is greater than 1. We have a vertical compression by a factor of a, and so that's if we have a times f of x and it's between 0 and 1. Basically, multiply all your outputs by a here. Now horizontal stretch by 1 over b, that's going to be when we have f of b times x, and that's when b is between 0 and 1, and it's compression when by 1 over b when f of b of x is b greater than 1. And again, all you're doing is multiplying your input by 1 over the b. So let's kind of look and just kind of describe how each of these graph transformations are from the original function. So, our original function is f of x, and so what did we do here? Now we have negative f of x. Well, what does that do? Well, that's going to be a vertical reflection. Okay, and again, this chart here will help you a lot. Here we have vertical reflection, okay? 2, f of 5x. Well, 5x, that means b is equal to x, or b is equal to 5. And so we're going to have 1 over 5 times all our x values is what's going to happen. And what does that mean? It's going to be a horizontal compression. horizontal compression by the 1/5. Now what about this one? Here we are multiplying, that's going to be our A, so A is 3. And then we also have a horizontal reflection. So we have two things going on here. And so we have a horizontal reflection plus a vertical stretch by a factor of 3. Okay. What about this one here? Well, that's just negative x here, so that's just a horizontal reflection. Okay. And again, some of these, they're the basic things. Some of them, you actually have to know what you're doing here. So here, B is 2. It's greater than 1. And so what we're going to do is we're going to have a horizontal compression by 1/2 because B is equal to 2. And so 1/B is 1/2. Now this one we have the opposite of f of x, so that means we have the vertical reflection, and then we also have this factor b of 3, so it's going to be a horizontal compression by 1/3. So we're going to have a horizontal by 1/3 because we have 1/b, and it's going to be a vertical reflection. Okay. Now here we just have some a times f of x. Well, a in this case is 1/4, and so we're going to have a vertical compression by 1/4. So we're just going to multiply it by 1/4, and so that's what we're going to do. We're going to kind of push it down. Now here, this is going to be our b. So b here is 1/3, and so now what we're going to have is we're going to have a horizontal stretch by a factor of 3 because 1 divided by 1/3 becomes 3. Okay. Now over here we have A, and so this is going to be a vertical stretch because it's going to be greater than 1, so it's going to be a vertical stretch by a factor of 6. And here we're going to have something just like this one. It's going to be a horizontal stretch by, now here b is equal to 1/5, and 1 divided by 1/5 is equal to 5. Okay. And so that's how we describe all the different graphs. And so again, you just kind of have to look at all the pieces. Here we just had a negative, so that vertical reflection. Here we had the negative x, and so that was a horizontal reflection, but we also had that 3, which was a, and so we had the vertical stretch by 3. And so you just have to look at all the little pieces based on original function of just f of x. And so what did we change to get to the new function g of x? All right, so that's the end of part 4.